بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. طلاب المرحلة الأولى، درسنا لهذا اليوم في موضوع Linear Algebra 2 المرحلة الأولى Bases of Vector Space. موضوعنا هو Bases of Vector Space. Bases you know bases in Arabic is أساس. Vector space you know. At the beginning, take definition of this definition. A basis for a vector space V is a set of vectors S such that we have to satisfy two conditions. First one, number one, V is equal to span S. V is equal to span S. The second condition is S is linearly independent. You know, if a set of vectors satisfy these two conditions, the first condition, V span S, that means this S span all vectors in V. يولد in Arabic يولد S تولد all vectors in V. And also the second condition, S is linearly independent. You know from the previous lecture what that means, S linearly independent. So if a set satisfies these two conditions, then we say that this set is basis for vector space V. This is definition of basis. Basis of vectors. A basis for a vector space V is a set of vectors S. This is spaces such that V equal to span S and S is linearly independent. Now example, we take example. Let V is equal to R2 times 1. Therefore, and B is equal to E1, E2. E is equal to E1, E2. And show that B is a basis for R2 times 1. Now we have to prove that this set B is a basis for V. That means we need to satisfy these two conditions. The first condition, V, that means R2 span S is equal to R2, and S is linearly independent. S is linearly independent. So first we have to show that we know, you know what solution, we know what mean E1 is equal to 1 0 and E2 is equal to 0 1. This is a standard basis. This is a standard basis for R2, and not just this basis, also there are other infinitely many bases for these vectors and other vectors also. So this is E1 and this is E2, and we have to show that R2 is equal to span S, that span here B. Okay, we say that this is set in definition S, and here B the same. This is not different things. Now I have to show that how this set span R2. Let, this is first condition, let x, y belongs to R2 times 1. All points in R2 times 1 are this, look like this. This is R2, x, y, pairs of ordered pairs. This is ordered pairs in R2 times 1. So now I have to show that this is ordered pair can be written as a linear combination of these vectors, these two vectors. So let x, y is equal to, look like this, C1, E1, or maybe we can move in the different thing. We can do it in the different way. Right here, start here, C1 E1 plus C2 E2. This is equal C1 anything, any real number in R, and let C1 C2 belongs to real numbers and we know E1 and E2. Now we can move it, substitute here C1 0, sorry, here 1 0, E1 equal 1 0 1 0 plus C2 and E2 equals 0 1. And now we can move this C1 here. This will be C1 and 0 plus, also move C2 here. This will be 0 C2, and now sum them. We can sum them. This is C1 plus 0 will be C1, and 0 plus C2 will be C2. And this is linear combination equal to this. And now we can choose, we can choose C1 equal X and C2 equal to Y. So this is equality will be, this is equal to, C1 equal X, and this is X, and C2 equal Y, this is Y. So this is linear combination of these two vectors, E1 and E2, equal to XY, and XY in R2, this is any point. This is any point in R21. So any point in R2 can be written as a linear combination of these two vectors, E1 and E2. So this is that mean That means these two vectors, E1 and E2, spans all values in R2, 1. This implies R2 times 1 is equal to span E1 and E2, this set. We can call B or this the same. There is equality here. So span E1 E2 equal to R2 times 1. That means we satisfy the first condition. Look, we can do it by example, and this will be clear better, I think, if we take some examples here in R2 times 1. Look here, 2, 3 belongs to R2 times 1, right? This is belongs to R time 2 times 1. How this will be written as linear combination of these two vectors, E1, E2? How? Look, this 2, 3 is equal to, or not start from here, start from C1 E1 plus C2 E2. This is equal C1 E1, we know it 1 0 plus C2 0 1 and this is equal, we can write here x y to know that that's not mean thing. C1 0 plus C2 plus 0 C2 plus 0 plus 0 C2. We can sum them, C1 C2. We need this to here, so should be from this equality we know implies C1 is equal to x and C2 is equal to y. So we can choose C1. What about x here? 2. And what about y? C2 equal to 3. So now that mean 2, 3 is equal to C1, that mean 2, and E1 1 0, and plus 3 C2 3, and E2 is equal to 0 1, and move and sum this 2 0, this 0 3, and this is 2 3. So we can write any vector in R2 times 1 by this way. Linear combination of these two vectors, E1 and E2. This is basis. So this is first condition, and the second condition we have to show that these vectors. Second condition we have to show that these vectors are linearly independent. How can do that? We take it in the previous lecture. We took it in the previous lecture. How I do this is two vectors are linearly independent. So make equality with 0. This is C1 E1 plus C2 E2. This is equality. Make it equal to 0. This is equal to 0. 0 belongs to R2 times 1. So I can here I have to prove that C1 0 and C2 0 if this is equal to 0. So here this is mean C1 times 1 0 plus C2 times 0 1. This is in R2, this means 0 0. So here this is equal to C1 0 plus C2 0 here 0 C2, this is equal to 0 0, and here sum C1 plus 0 0 and 0 plus C2 is equal to 0 0. From this equality we get implies that C1 is equal to 0 and C2 also is equal to 0. Therefore E1 and E2 are linearly independent. And this implies B is equal to E1 and E2 is a basis for R2 times 1. Look, here we satisfy two conditions. The first conditions S, this set here, our set here B, E1, E2 span E1, E2 equal to R2. This is first condition of basis, and second condition linear independent, and we prove that these two vectors E1 E2 and get C1 0 and C2 0. So E1 E2 are linearly independent, and we do two conditions so that B is a basis for R2 times 1. This is page number 1 and this is page number 2. Now we take another example. Let also the same vectors, let V is equal to R times 1 and B is equal to, here we take different bases, E1 comma E1 plus E2. This is basis also show that B is a basis for R2 times 1. Solution. The same way we take we have to show that B span P equal to R2 times 1, and B also we have to show that these vectors are linearly independent. So now we can check condition 1. Check first condition. That means this set span set equal to, also we take let x y belongs to R2 times 1. This any point. How can I write this point as a linear combination of these two vectors, this first vector and this is second vectors? In the previous example just E1 E2, and here E1 and E1 plus E2. There's different pieces. So how can I do this point write this point as a linear combination of this. So I can write this x, y is equal to C1, E1, this is first element, plus C2 times E1 plus E2. This is second element. This is first element here first element E1, and C2 with this E1 plus E2 second element. Now try to find the value of C1, C2. Try to find these values. How? And if we find these values, so I can do it by anyway. So this is write it as a linear combination of these two vectors. This is will be C1 E1, that means 1 0 plus C2. This will be what? This is E1 1 0 plus this is what? 0 1 E2. So here we can sum, and here we can move it C1 0 plus C2 still out, and this is sum will be 1 1 1 plus 0 1, and 0 plus 1 1, and this is now we can move it here, and this is will be C1 0 plus C2 move here C2 and this is will be equal to C1 plus C2 and here comma 0 plus C2 will be C2. So I have now two equations. This is first equation. This is equal what? Equal x. And this is equal what? Equal y. So C1 plus C2 equal to x. And the second condition, C2 equal to y. So I can do this linear system. The variables here are C1 and C2, and we know this. I know this point because I give this point already. I have this point, so I have to find C1 and C2 here in this linear system. I think this is easy to find it. Just move C2 here, and we know this is from this we know C2 is equal to y. I know that, and from this we can see C1 move here y plus y is equal to x, and here implies C1 is equal to x minus y. And so a linear combination, this, look, if I take C1 x minus y and C2y, I can write any point in R2 as a linear combination of the first element of the set and the second element. So how can do that? This linear combination C1 E1 plus C2 E1 plus E2. How can I do that? This equal to xy, any xy, for any xy. So if I know C1 equal to x minus y, substitute here x minus y instead of C1, put x minus y, E1, and E1 instead of E1 put 1 0. This is equality, and here this is plus C2. What about C2? C2 equal to y, and here put y, and here put instead of E1 put 1 0 plus instead of E2 put 0 1, and sum this. what you will get. This will be equal here x minus y, comma 0. So this is move here, here and here. This is x minus y times 1 will be x minus y, and x minus y times 0 will be 0. Plus sum this and move y will be y, because this is will be 1, 1. 1 plus 0, 1, and 0 plus 1, 1. This will be 1, 1. Move y inside this 1, 1 will be y, and sum these two vectors. X minus y plus y will be x minus y plus y, and 0 plus y will be y, and here this is will equal to x minus y plus y. This is will be 0, and this is x, y. So any point, any vector in R2 times 1 can write it about linear combination of these two vectors. This is first vector and this is second vectors, such that should be C2 equal to y and C1 equal x minus y. This implies, this is page number 3, this is will be implies that span E1 plus E2 equal to R times 1. This will be equal R times 1, 2 times 1, and you know this is first condition. This is first condition. I can do by example also to know. I can do it by example. Will be clear better, I think. Will be clear if I do by example. Take this point also 2, 3 in R 2 times 1. 2 times 1. How you can write this point as a linear combination of these two vectors, this vector and these vectors. I know already C1 should be equal to x minus y. C1 is equal to, I write linear combination C1 E1 plus C2. This is E2, this is two vectors, this is vector, second vector, E1 plus E2. If I choose here C1, this is will be equal, C1 is equal to x minus y, x minus y, x2 minus y 3, 2 minus 3 will be minus 1. Minus 1 E1. E1, what about E1? E1 equal to 1, 0. This C2, what about C2? C2 equal to y. I know already C2 equal y, and C1 equal x minus y, and C2 equal y. So C2, this is equal to y. Y, what about y? Y is 3. So 3, and no, E1 equal to 1, 0. E2 equal to 0, 1. And now we can show that this will be 2, 3, equal to 2, 3. Move here, this is will be minus 1 and 0. Move here and here. And this will be, sum will be 3, 3. If I sum this, 1, 0, 1 and 0, 1. Will be 1, and this is will be 1, 1, and move 3 will be 3, 3, and sum this will be minus 1 plus 3 will be 2, and 0 plus 3 will be 3. So we write 2, 3 these vectors as a linear combination of these two vectors, this first vectors and this is second vectors. Now I think this is clear. This will be span any vector in R2 times 1. Now I have to show that this set is linearly independent. Check condition, second condition. I know how from previous lecture, how can I check the set is linearly independent? I take linear combination, make equality with 0, C1 E1 plus C2 with second element E1 plus E2, and make this equality with 0. 0 will be belongs to 2 times 1, and here I try to find C1 and C2. C1 here, and here E1 equal 1 0, and plus C2 equal to, this is will be 1 0, this is plus will be 0 1, and this also here equal to 0 0, you know, 0 0. And now move here C1, this is will be C1 0 plus, and sum this C2 out, and here will be 1 1. This is equal to 0 0, and move this here. This will be C1 0 plus here C2 C2. This is equal to 0 0, and now sum these 2 points will be C1 plus C2, C1 plus C2, C1 plus C2, and this is second argument will be just C2 equal to 0 0, and here this is equal to what? Equal to 0, and this, I know that this C1 plus C2 equal to 0, and C2 is equal to 0. I know this C2 equals 0, direct C equals 0, and if I put 0 here, will be C1 also equal to 0. This implies that C1 equal 0 and C2 equal to 0. So the set B is equal to E1 plus E2 is linearly independent. Now this implies that the set B is equal to E1 plus E2 is a basis for R2 times 1, and this finish. It's page number 4. Finish this example. I can take another example also. Another example. Let R2 times 1, this is will be V, and B is equal to E2 E1 plus E2. You can make here minus or plus. Show so that B is a basis for R2 times 1. Solution. Also the same way, we can first check first condition and check first condition. Should be the set span all vectors in R2 times 1. Let I take any point x, y. This is any point in R2 times 1. How can I write this point, any point, this general form? How can I write this point as a linear combination of these two vectors? The same way, try to find C1 and C2. Make equality x, y. This is equal to C1. First vector here E2 plus C2, and second element here E1 plus E2. And try to find C1 and C2. If I find them, C1 is C2, so I can write any vector in as a linear combination of these vectors. Now make this substitute here C1 and here 1 0. Sorry, this is 0 1. This is E2. E2 0 1. E2 0 1 plus C2. This is E1 1 0 plus E2 will be 0 1. And here this is will be equal, move here, this is will be equal 0 C1 and plus sum this first sum, this will be 1 1, and move C2 here, this will be 0 C1 plus C2 C2, and now sum, you can sum. This is will be C2 C1 plus C2, and now we get from this equality C2, what about C2 equal x, and C1 plus C2 equal to y. The second argument and this first argument. C2 equal what? Equal x, and C1 plus C2 equal what? Equal to y. So now I do this system. Try to find values of C1 and C2 here, and I know what the values of x, y. I know these values. Just try to find C1 and C2. So from this first equation, I can know that C2 equal to x, C2 equal x, and put here C2 x. If I put here, and from this equation C1 plus x equal to y, because C2 equal x, and this is will be implies C1 equal y minus x, right? So now I know value of C2 equal x and value of C1 equal y minus x. So if I take C2x and C1 y minus x, I can write any point in R2 2 times 1, a linear combination of these two elements here, E2, E1 plus E2. I can do that. This is C1, E1 plus C2, E1 plus E2. And here, put instead of C1, I know what value of C1. Y minus x. Put here instead of C1, and E1, you know what about E1. E1 1 0, you know value of A1, and here C2, you know value of C2, I get it X, and this is A1, you know A1 will be 1 0 and plus this 0 1 A2. Now can move this here, this will be y minus x 0 here, move here and here, and this is sum. If I sum 1 0 1 0 1 1, move x will be get x x, and now you can sum this y minus x plus x, 1 minus x here, sum with this x, and 0 plus x will be x, and this is will be x minus x will be 0, and here just y, and here this will be I think there's something not correct. I have to do it at the first thing from the beginning. X equal C1 E2, C2 E1 plus E2, here E2, and this is E2 0 1, and this is E1 1 0, and this is E2 0 1, and this is C2, and move here, this is 1 1, and this is will be 0 C1, and this is will be C2 C2, and this is sum, so C2 equal to x, and C1 plus C2 equal to y, C1 plus C2 equal to y, and C2 equal to x, put here instead of C2, and move here, C1 will be equal y minus x, and here, so this is correct, and here C1 equal to minus y minus x, and C2, this is, oh, here this is wrong, this should be E2 not E1, this should be E2, so here I have to write E2 because this first element, the first element is E2, here E2, and here E2 0 1, here E2 0 1, and this is correct, and here will be, this is wrong, this is will be 0 0, because this is move here y minus x, and here 0, and here the same, and here, okay, this is not correct, you can do it, okay, I will repeat it, this is move here 0 will be 0, here y minus x 0 0, and y minus x times 1 will be y minus x plus, and this is will be x x, and now sum them will be x, and here y minus x plus x, and this is will be equal to x, and minus x minus x will be 0 x y. So I write all linear combination of x y as this, by this way, a linear combination of these vectors E2, sorry, you know this, any wrong will be still wrong, so you have to do it perfectly to avoid the wrong. That now this implies, this page number 4, sorry, this page number 5, yeah, and now This implies that B is equal to E2, E1 plus E2 is span are 2 times 1, i.e. span E2 E1 plus E2 is equal to R times 2 times 1. Now check 2. Check second condition. I have to show that these two elements are linearly independent. I know how can I do that? C1 E2 plus this first element C1 E2 plus C2 second element E1 plus E2. Make equality with 0. This is in R2 times 1. So now try to find C1 C2. Try to find C1 C2 from this equation. Move here, put here E1 E2 equals 0 1, E2 equal 0 1, C2 equal here 1 0 plus 0 1. This is equal to 0 0, and move here will be 0 C1 plus C2, sum this will be 1 1 equal to 0 0, and this will be move here 0 C1 plus 0 C1 plus C2 is equal to 0 0, and here sum this factor 0 plus C2 will be C2, and here C1 plus C2 equal to 0 0, and now we get from this system C2 equal to 0, this is equal to 0, and this is C1 plus C2 also equal to 0. So I get this is here equals 0, and I can put here from this system C2 equals 0. I get already it, and here put here from this equation we get C1 plus 0, because C2 equal to 0, this implies C1 also 0. So I get C1 equals 0 also, and also C2 equal to 0. So this is that mean B is a linearly independent. So B is a linearly independent. That mean this implies B is equal to E2 E1 plus E2 is a basis for R2 times 1. This is page number 6. And now we take 3 examples. All these examples are bases for R2. And now could I get example, not basis, example? let v is equal to r 2 times 1, this is vector space, and b is equal to E1 and this is 2, 0. Show that B is not basis for R2 times 1. That means if B is not basis, that means one of these conditions will not satisfy. One of these conditions, either this first condition or second condition. Which one will be not satisfied? I think in this example, the second condition will not satisfy. Look, solution, check 2. If one not satisfied, so I can say this set is not base for these vectors. Check 2. Try to check 2. Is these vectors are linearly independent? E1, I know. What about E1? E1 will be equal 1, 0. And right, and this is, you know, this is, I get it. So C1, E1 plus C2, this 2, 0. This make equality with 0, 0, and try to find C1 and C2. And this is E1 equal C1, this is equal 1, 0, and plus C2, move here. Okay, the next step, 0, 0, and now move here. This is will be C1, 0, and this is will be 2C2, 0, equal to 0, 0. Now sum this will be C1 plus 2C2, and this comma here, and 0 plus 0 will be 0, 0, 0. Now look, we get just one equation, this equation, and C1 0 equals 0. I know, so I didn't benefit from second argument, just from first argument. C1 plus 2C2 equal to 0. I get from this C1 is equal to minus 2C2. That mean if I take C1, this C1, this C2. If I take C1 0, also this is will be, if I take C2, sorry, C2 0, also C1 will be 0. If I take C2 1, that means this C1 equal minus 2. And if I take this minus 1, this will be 2. If I take this 2, this will be minus 4, and so on. That means there is no unique solution. There are infinitely many solutions. So B equal to E1 2 to 0 is linearly dependent. This implies B is equal to E1 and 2, 0 is not basis, is not basis for R2 times 1. This finish. Just one. If I know just one condition not satisfy either the first condition, S will not span V, either or second condition, S is not linearly independent. Just one condition, I know it not satisfy, so I can say that this set is not basis for this vector. Look, I think this is enough for today. Thank you very much. Goodbye.